Hi everyone, I'm Ms. Cho, and today we'll look at how to solve systems of equations using substitution. Substitution is an algebraic method that uses what you know to find things that you don't know. Let's take a look at an example using a riddle. So I want you to take a moment to pause and try this on your own. Can you figure out how much one pepper, one taco, and one corn dog is? We'll work through it together when we come back. So what I notice is that the first row is pretty easy. We know that 3 tacos gives us 60. So that means each taco is 20 because 20 plus 20 plus 20 is equal to 60. Now that we know what a taco is, we can in place write a 20, and then now we just have to figure out what the corn dogs are. We know that 20 plus 2 corn dogs gives us 30, so that means that 2 corn dogs must add up to 10, which means each corn dog should add up to 5, because 20 plus 5 gives us 30. Okay? And then once we know what a corn dog is, we can replace that with the number 5. And then we have 5 minus 2 peppers is equal to 3. Well, that means the 2 peppers have to add up to 2, which means each one is 1, because 5 minus 1 minus 1 is equal to 3. So let's look at this algebraically as a system of equations. In the first line, we have 3 tacos is equal to 60. The second line, we have a taco plus 2 corn dogs is 30. The third line is a corn dog minus 2 peppers is 3. And then the last line is a pepper plus a taco plus a corn dog is some number. And so in every case, we started with what we knew, which was that a taco was 20, because we could just divide by 3. And so once we know that a taco is 20, we can replace that in the next equation, then find what a corn dog is. Once we found the corn dogs, we could replace that in the next equation and find out what a pepper is. Then we could substitute and replace that in the last equation to find what the total value of one of each thing is. This is an example of substitution. You use what you know to find what you don't. Let's take a look at what this looks like in a given system of equations. Here I have 2 lines. I have y is equal to negative 5x plus 13 and 4x minus 2y is equal to 16. I could just graph this because the first one's already in point slope form, but then the second one, it's not as easy. I gotta move things to the other side, I gotta divide, and I don't want to deal with that. Luckily, there's another way to solve. I notice that I'm working with the same variables, x's and y's, and also the first one just straight up told me what y is. So that means that in place of the y in the other equation, I can just substitute the value, which is negative 5x plus 13. So I can rewrite this as negative 5x plus 13. I can use the distributive property. A negative 2 times a negative 5x is a plus 10x. A negative 2 times a positive 13 is minus 26. And then I have like terms of 4x and a 10x gives me 14x. Minus 26 is equal to 16. I can add 26 to both sides. And then that leaves me 14x is equal to 42. And then I can divide each side by 14 to give me x is equal to 3. Now you might be tempted to stop here because you found a solution, but that would be like saying, I found a taco, I'm done, when in fact you still have other foods to find. So remember, a solution to a system of equation is an ordered pair, and right now we just have the x value, we don't have the y. But now that we know the x, we can go substitute back in to any of the equations. I'm going to use the first one, and we can find our y from there. So our first equation is y is equal to minus 5x plus 13, and then in place of the x, we'll substitute the 3. That gives us minus 5 times 3 is minus 15 plus 13, and that's negative 2. So our solution is 3 and negative 2, but remember you have to check whether it satisfies both equations. I'm not going to do it here, but you should try it, and you want to make sure that it makes both equations true. So how do you know when to use substitution? I'll give you 3 scenarios. One is when they give you one of your lines as a y equals form. You know that y is equal to something, you can substitute it into the other equation where y appears. This is important. You must substitute in the other equation. Otherwise, it doesn't tell you anything useful. The second scenario is when they give you something in the form of x equals. So the same thing. You can just substitute the value where x is in the other equation. And the third is when x or y is easy to find. Here, they don't explicitly give you an x equal or y equals, but I can see that, oh, it's pretty easy to find what y is. I can just subtract 3x from both sides, and that gives me y is equal to minus 3x plus 7, which I can substitute in the other equation. So that's all for substitution. If you have questions, please let us know. Otherwise, I'll see you next time.